Now we're going to look at some proofs that you're going to see more of in the next section, but just give you an introduction to proofs involving angles and ones involving segments as well. For this, we have this logo here, and it's used to sell daffodils. We want to prove, I'll show you real quick, that angle EBA, which is this angle right here, we want to prove that that is congruent to angle DBC, which is this one right here. Now, when you do proofs like this, what you want to do is kind of map it out ahead of time. And this will be a little tricky at first, but you'll get used to it. Now, we want to prove, again, EBA, let's go back one. We want to prove that this angle DBC and this angle EBA are equal. If we look, the measure of angle EBA is made up of two angles. It's made up of angle 2 and angle 3. And we know this because of the angle addition postulate. So literally, two small angles equal a big one. If we look at the measure of angle DBC, we know that that is equal to the measure of angle 1 plus the measure of angle 3. Whoops, sorry, plus the measure of angle 2. So these two angles right here. Now, we know a couple of other things. It's given to us in the picture that the measure of angle 1 equals the measure of angle 3. And we can tell that because of these markings right here. We also know, even though this is obvious, we know that the measure of angle 2 is equal to the measure of angle 2. And this is one of the properties of equality that you learned in this section called the reflexive property. So we would do these things first, because it's given to us, and the second one because of the reflexive property. Then what we can do is we can state that 1 and 2 is equal to 2 and 3. I'm sorry. Yeah, once we do that, what we can do is we can say, if this is true, we can add the measure of angle 2 to both sides, and we can get the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. So in other words, what we did was we just added 2 to both sides. If that's true, then we know these two things are equal, because we know that the measure of angle EBA is 2 and 3, and the measure of angle DBC is 1 and 2. So that's basically what this is saying here. So our last step would be that the measure of angle EBA is equal to the measure of angle DBC. Okay? So we're just kind of mapping it out, just writing out things that we know are important. And we're going to start out with what's given to us, and then the obvious stuff, and then we'll, from there, we'll write out these ideas, and we'll use that to write an equation that's equivalent to what we're trying to find. So let's take a look at what this would look like altogether. So again, you won't need to do the explanation. You can just do the equation and the reasons, or in this case, the statements and reasons. So what's marked in the diagram is that 1 and 3 are congruent, and again, the reason for that is given. The next thing we want to look at is that we can add, well, we know that EBA is these two added together, 3 and 2, and that's because of the angle addition postulate that we learned a while ago. We can also state that, and they're doing it slightly differently, but that's okay. We can substitute in 1 for 3 because those are equal to each other. So we can state that EBA is 1 and 2 because 3 and 1 are the same. Whenever we replace one thing with another thing, that's called the substitution property. And since 1 and 2 is equal to DBC. We know that's the angle addition postulate. So if you look going back and forth, we know that EBA is equal to 1 and 2, and we know that DBC is equal to 1 and 2. Therefore, since they're both equal to 1 and 2, we can set them equal to each other. And again, what we did here in this case was the transitive property, which is another property that you learned. And let's go back and see why it's the transitive property and not substitution. We've got the first one equal to the second one. We've got the second one equal to the third one. And so the first and the last are equal to each other. That's transitive property. Very similar to the law of syllogism. So again, this is introduction to this. We'll do more of this in the second section. Study this carefully so that you understand the process that we went through. Now we're going to do a similar proof with segments and the segment addition postulate. So if we look at this, we want to prove that AC and BD are equal. So we're just going to go through it real quick the same way we did with the last one. Again, instead of equation, we'd put a statement here and a reason. We're going to start out with what's given to us. And what's marked in the diagram is that AB and CD are equal. And a reason would be given. The next thing we want to do is we want to add lengths of adjacent segments. So what we can do is say AC is equal to AB plus BC, because we want to eventually get to AC is equal to BD. So we know that AB plus BC is equal to AC. This is the segment addition postulate. Then, since we know that AB and CD are equal, well, they're doing it a different way. We know that BD is also two segments added together. So BD equals BC plus CD. And that is also the segment addition postulate. Our next step. We know, if I go back one, since I know AB and CD are equal, I can add BC on both sides. And we're going to get this. That's the addition property of equality. We know that AB plus BC is equal to AC, and we know CD plus BC is equal to BD. So since these two equal BD and these two equal AC, we can state that those are equal to each other. And again, what we've done here is we've substituted, since this is equal to this and this is equal to this, we use substitution property. So very similar problems solved two different ways. Either way would be okay. Now for these last couple of examples, all you need to do is name the property. You will get problems like this, I believe, on your quiz and also on your test for sure, on your quiz and on subsequent quizzes and tests. For this one, all we've done is we've switched the 6 and the 7, and remember, whenever we do that, we're using the symmetric property of equality. Here's another one. We have the first equal to the second, second equal to the third, so first and last are equal. That's the transitive property of equality. And here's one more, where something's equal to itself. We call that the reflexive property of equality. And that's it for this one. Thank you.